All right, guys, we're going to be looking at section 2-5 on using linear models. This particular section, the goal for this, the I can statement is I can write linear equations that model real world data, and I can make predictions from those linear models. So this is going to be a really practical lesson today that we're going to be looking at, as well as this is something that you're going to see a whole lot on ACT science test, a lot of different areas. Okay, so let's just get into this. It says right off the bat, the top line right up here, the strength of the relationship between data sets is called a correlation. Okay, so it talks about, first of all, a positive correlation. It says a positive correlation is data points that fall close to a line with a positive slope. So let's just think about this for just a minute. I'm going to try to give you a good practical example. And this is something you'll see quite a bit as well. Along this x-axis, let's just call this minutes spent studying. So if you spend, say, 0 right here at the origin, then if we were to look at this as being test scores, for example, so time studying versus test scores, we know by now, we're juniors. We know by now that if we spend more time studying and actually trying to absorb the content, that more times than not, our test scores are going to go up. Now, you can see here there's some dips up or down. It's not a perfect straight line. We know there's things that happens. We have bad days, whatever the case may be. But we know that there is definitely a positive correlation between time spent studying and test scores. Okay, so you notice if you were to draw a trend line right up through the middle of this, that most of these data points, they're on either one side or the other. So what we're really saying is an increase in X, whatever X is, in this case it's time studying, is going to produce an increase in test scores. Conversely, you see here negative correlation. So it says negative correlation is data points fall close to a line with a negative slope. So again, if you were to draw a line here, you can see that most of those points are really, really close to that particular line. And so again, if you try to use an example here, if I spend more time, you notice I'm using time a whole lot. That's because you'll see that a whole lot. If I spend more time exercising, if my time exercising goes up, then I can pretty much figure out that my weight is going to go down. Okay, so my weight is going to go down as I spend more time exercising. Okay, so it kind of gives you an idea of both of those scenarios. And then here you have one that says no correlation. In other words, data points. Let me go back to this one real quick. Negative correlation. So if you increase X, notice if I start here and I go this way, I'm increasing my time in exercising, but it's actually producing a more negative result in my Y. Okay. So again, here I'm increasing X and I'm also increasing Y. Here I am increasing X, but I am decreasing Y. Okay. Now let's look at no correlation. So no correlation says data points are scattered and do not fall close to any line. So there's not really any line that I could produce that I could say, hey, these points are really, really close to it. We've got a few that maybe this might look negative, but we got one way out here. And so a good example of this would be if I'm increasing an X, let's call this eating more Whoppers. All right, this is my number of Whoppers I eat every single day. Okay, and this is my height. Well, those two things have nothing in the world to do with one another. Maybe if I'm taller, maybe I eat more Whoppers. I'm not sure, but those two things are not really going to correlate. For example, I could be 5 foot tall, but I eat more Whoppers, and guess what? My dot's going to be way over here somewhere. So there's no real correlation between that data, and so one of the things you got to be able to do is to try to figure out whether there is, in fact, either a positive, negative, or no correlation at all, just simply from a data set. So let's look at one example here, and I'm going to skip this one. This one's kind of already done for us. Let's look at this one. It says, make a scatter plot and describe the correlation. And you notice it just gives us this set of numbers. You see the little brackets here on each side, so that's identifying that is in fact a set. So it's giving me a set of numbers, and it's asking me to make a scatter plot and describe the correlation. Now, I could get out a sheet of graph paper, and I could just try to go at it, right? See the best way to try to do this. Didn't have this planned out real well. So the first point is 0, 10. So I could go here 0, up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could put my 1 point right there. I could then go to 2, 7, over 2, up 7, 1, 2, 3, 4, 5, 6, 7. You can see by now that this is getting old already, okay? If I'm going to do 20 points, I'm going to be doing this for quite some time. There has got to be a better way to try to do this and to be able to see if there is, in fact, a correlation or not. So here's what I'm going to do. I'm going to take this same set of data that we have right here, this number 1, and I'm going to show you something on Desmos that's really, really, really going to help you when you get into this assignment that you're going to have today. All right, so I'm going to switch over to the Desmos screen real quick. And here's what I'm going to do. You notice this is the way we usually see it. It just comes up, and we've looked at this before. You could put in 2x plus 2, and right now it's zoomed in. So I'm going to zoom it back out some, and you can kind of get the idea. There's the graph. Okay, yes, Mr. Hamilton, it will graph, big deal. I've got 5 sets of data points that I need to put in. Okay, so here's what I want you to see that you can actually do with the power of Desmos. So I'm going to exit off this, and here's what I want to do. I want you to go right up here to this plus arrow. See, it says add item, and if you click that, you will see that it gives you all kinds of different options. Well, right here you see an option that says table. All right, we're going to go ahead and click table. And you notice that I can begin to put in X and Y coordinates. Now, we already have those X and Y coordinates. They're right over here. I'll bring them back up again for you. So there they are. So what I'm going to do now is type in these X and Y coordinates right into Desmos so that you can see it. So again, I'm going to put my X coordinate in of 0, my Y coordinate in of 10. And if I just tab, it will let me go down to that next column. Then I have 2 and 7, 4, 5, 6, 2, and 10, and 1. And again, I got those from right here. There's my 5 ordered pairs. I basically just, this is my X coordinate, this is my Y coordinate. I just put them into a table instead of listing them out like we usually do in ordered pairs. And look what happened over here. So you can see here it plotted all of those points for me. And if you look back again at what we already looked at, see if you could pick out which one of these maybe this looks like. So here's our choices: positive correlation, negative correlation, or no correlation at all. Let me let you look at it one more time. There are your points here. Kind of see the motion I made with my line, and then go back and look here. Well, is it a positive correlation, a negative correlation, or no correlation? Well, just by looking, again, one more time, you can tell that that is a positive negative correlation because, or a negative correlation, not positive, I'm sorry, a negative correlation because the points, if I were to draw a line, they're really, really close to what I have, okay? So on this question right here, we'll go back down to the question, make a scatter plot and describe the correlation. Well, the correlation here is going to be a negative correlation, all right? Now, you'll also notice that they give us things like this. They give us a table, and they're wanting to know that if the calories have a correlation between the vitamin C. In other words, if a juice has more calories, does that mean it also has more vitamin C or maybe less vitamin C? Is there a correlation between the calories and the vitamin C? So what we can do with this right now is we can go ahead and we can just go ahead and assign this will be my X coordinate and this will be my Y. We'll just see if there's a relationship or not. Okay, it's kind of hard to tell which one depends on which. So we'll just make one X and one Y. Okay. Now let's do the same thing that we did on this group here. We'll go to Desmos and we'll put in these. And again, these are kind of my ordered pairs. So in other words, for orange, this would be my X and this would be my Y. For passion fruit, this would be my X and this would be my Y. So these are like my ordered pairs, the 112 and 124. is an ordered pair. The 148, the 45 is an ordered pair, etc., etc. So what you would do, go back into Desmos, and I'm just going to write over the ones that I already had there. Okay, so I'm going to go ahead and do 112 and 124, 148, 45, 170 and 60, 117, 103, and 268 and 121. Now, again, if you look over here at your graph, you're going to see that there's nothing there. Well, it's because these numbers here, they're really, really, really big numbers. So I'm going to have to scroll out. It's okay. We can take the time to do this. And I see that I have 5 data points here and I have 5 data points here. Now, just by looking at what you see, again, if we were to try to sketch that, it would have been really, really hard to sketch that graph out. But here, Desmos has did it for me. And you could probably very quickly see what kind of correlation this is. So again, take a mental image of the graph right now, and then let's go back to what we looked at before, the different types of correlation. So is it a positive correlation, a negative correlation, or no correlation at all? Well, again, looking back at our graph one last time, you see that there's really no correlation at all. The data points are all over the place. So we can conclusively say that there is not really a correlation or connection between calories. Let me go back to that question real quick. Describe the correlation. Well, there is no correlation, and we can say with confidence that the calories or the vitamin C does not depend on the calories. It can go either way. So in other words, something can have a whole lot of calories yet not be near as big in vitamin C as maybe something else that has lower calories. So there is no real correlation there. So that would be your answer. Okay. So now let's look at the second page of this, and it talks about trend line. It says a trend line is a mathematical model that shows the relationship between two sets of data, and a trend line can be used to make predictions. So again, I want you to think about maybe something like the weather. Is the weather always spot on? Well, no, they use percentages. And one of the funniest ones I think is when they say, well, there's a 10% chance of rain. Well, what they're really saying is we don't think it's going to rain, but if we say that there's a 0% chance and then it does rain, everybody's going to be mad, right? So they try to make predictions based on what they see. And so this is really common right now, especially in the situation that we're in with COVID-19. You see all these different news reports that say, we think this trend is going to be this or that. You see positivity rates. You see all kinds of different predictions that are being made. So we can do the same thing using the tools that we have. So let's look again. This example is kind of already done for us. So let's go down here and let's work a live example. And these are going to be the type questions you're going to have, which are going to kind of be multi-part questions. Okay. So you're going to have to be able to try to figure out how to do this. But again, I want you to notice it says use the data in the table, and it says total U.S. population enrolled in Medicare. And so it has years listed here and the population in millions that are enrolled in Medicare. You notice it starts at the year 2000, goes 2001, 2002, all the way through 2005. So the first thing it tells us to do is to draw a scatter plot. So again, we can kind of see that this year, and I've said this a couple times already, but more times than not, anytime that you're dealing with time itself, you're going to use that for your x-axis, okay? So we could put these years down the x-axis, okay? This could be our x-axis, and then the population is going to depend on the year, right? So we're going to call that our y-axis, and so this really becomes our ordered pairs if you think about it. Now we're going to make this a little bit simpler on ourselves, and this is something I encourage. I'm sorry, I shouldn't have did that. This is another ordered pair. So all these are my ordered pairs that I'm going to use. But one of the things that you're going to learn pretty quickly to do is this is the year I'm starting with, right? This is my first year. So this is really like year 0, okay? And you notice it's even got a 0 at the end. So I'm going to use that as my x coordinate. Instead of putting 2000, I'm going to use 0 so that it makes it a little neater, and it'll make more sense once we get down to this other part of the problem that we're going to see. All right, so we're going to use those as our x values, and these are going to be our y values. So I'm going to jump over again, and this time we're going to add something else that we're going to do on Desmos, and I'll show you that in just a minute. So we're going to go to Desmos again, and again, I'm just going to rewrite over top of these. So I can just highlight like that. And again, we're going to start with the year 2000, but instead of 2000, I'm just going to put a 0. And here I'm going to put 39.7. Here I'm going to use year 1 or 2001, representative for 2001 was 40.1. Year 2 or 2002 was 40.5. Year 3 was 41.2. Year 4 was 41.9. And year 5 is 42.6. Again, you can see they're all bunched up here because I had it zoomed out just a minute ago. I can zoom that back in. You can just use your wheel or your mouse and zoom back in right here on Desmos. And you should already be kind of thinking about the fact, okay, what kind of correlation is this really? Okay. And again, here's where I got my data from, right here. So that's where I got my ordered pairs from. It told me to draw a scatter plot. Well, I've used Desmos to be able to do that. So I know that correlation-wise, this definitely has a strong positive correlation. These, if I were to draw a line, these dots are really, really close to those lines. And so it brings me to my second part here. The second part says draw a trend line and write its equation. Now I could just arbitrarily just draw a line, just draw a line like that across my screen. But this is the more difficult part. How am I going to write an equation? And let's think about what an equation really has. An equation, something we've used quite a bit, slope-intercept form, is y equals mx plus b. So every equation has this basic stuff within it. Well, what does it have? It has a slope, and it has a y-intercept, right? And it has an x coordinate and it has a y coordinate, really. So how can I figure out how to write an equation? This is where Desmos is really going to help us out. All right, so here's what we do. We go back to Desmos. And again, it wants me to draw a trend line, and it wants me to write its equation. So here's what I'm going to do. And you're going to have to follow this instruction really, really, really close. So I'm basically going to use what I said about slope-intercept form, y equals mx plus b, to help me with this process. So the first thing I'm going to do is I'm going to put a y right there. And then you're going to need to go to your little keypad here. See how it says hide keypad? You can bring that keypad back up, okay? And you can see if you hit this button right here that says ABC, it will bring up a whole nother menu. And you'll notice right down here, you see a little A with a subscript B, okay? So if I hit A subscript B, it will allow me to put a little subscript number right there. And you notice as soon as I do that, as soon as I put Y sub 1, it says it equals a 6-element list. So it's if you will, it's referencing this list up here. You see how it's got Y sub 1 and here it has X sub 1? So it's already kind of looking at that, okay? Now you could do your right arrow. See how that changed that cursor to a bigger cursor? And you also have another little symbol right here that is like a little squirrely line, okay? So you hit that little squirrely line. I'm sure there's an official name for that, but Mr. Hamilton does not know what it is, so I call it the little squirrely line, okay? So you can kind of see it's like an equal sign, but it's not. So then here we're going to put M, and notice it starts trying to do some other stuff, okay? And then we're going to go ahead and put X, and we're going to tell this, hey, you need to look at this X1 column. So I need to do the same thing again. I'm going to do this little A sub B, and it's going to let me put a subscript 1 right there. Notice what happens now all of a sudden. It's trying to put a line, and it's giving me some other information, but I'm not quite done yet. So I'm going to right arrow one more time, and it's going to make me a big cursor right there. And I'm going to go ahead and put the plus B, okay? Now all of a sudden, look what I have. Now I have an M value right here, and I have a B value right here. Okay? So what I want you to notice is it is not only giving me this line, this trend line, based on those points that I put on there, but it's also giving me the equation of that line. So watch what happens down here. I'm going to go ahead and put in y equals 0.588, because that's what my M value is right there, x plus, notice my B value, I'm going to go ahead and just put 39.5. And notice what happens to that line. That line is basically right on top of my trend line. So this right here is the equation that it's asking for. And Desmos did it all for me. I just have to be able to put in this format right here in order to be able to do it. So when we go back over here to this part where it says write its equation, it would be y equals 0.588x plus, let's go back and look at that again real quick, y equals 0.588x plus 39.5. And there is my equation right there. Okay? Now you say, why is that important for the last part? So the last part says this. It says use your model to predict the number of Medicare employees in 2015. And remember, this is a prediction, so it's not always going to be exactly the same. Matter of fact, some of your answers may be totally different, and that is okay. It's fine. It's a prediction. But as long as we get really, really close. So it says use your model to predict the number of Medicare employees in 2015. Now remember what we did when we graphed. We used this as 0, the year 2000 is 0, the year 2001 is 1, the year 2002 is 2. Here's where that becomes important because we're talking about 2015. So these were my X values. In other words, I put in a 0, I got out a 39.7. So in order to find the number of Medicare enrollees in 2015, I'm going to take this 15 right here, which is all I'm worried about. I'm not worried about the 2015. I'm going to take this 15 and I'm going to input it for my X right here, and it's going to give me a certain value of Y. Okay? So again, I could go back to Desmos if I'm using that for a calculator, and I could go ahead and put in 0.588 times 15, because that's the year that I'm looking for, plus 39.5. And look there, it's going to give me that estimation or that prediction of how many Medicare enrollees I'm going to have in 2015, which is 48.32. You can see my answer right there. So right here, my answer is going to be 48.32 million, right? Because the population on the particular question here is in millions. So hopefully this has been helpful, and we can do anything to help you further with this. Make sure you let us know.